So here in example number 2, we need to find the equation of a line passing through this point. So I have x naught, y naught, and I have z naught. And it is perpendicular. Perpendicular means it's orthogonal. It means this vector is a normal vector. So this will be A, B, and C. So what we need to solve this question as a solution, we just need to write the equation of the plane. What's the equation for the plane? It's actually, we're gonna be A, and then we multiply A by x minus x naught, plus B, we multiply it by y minus y naught, and then we will do C, and we multiply it by z minus z naught. We add them all, the answer should be 0. Now, all what we need to do is we need to write the value for A, B, C, and we write the value for z and z naught and y naught. So A, B, C, it would be -2. Here we write 1. Usually we don't need to write this 1. Finally, we write C as 5, and then we write the value for the point, which is 6, 3, 2. Now we can keep this equation as is, or we can take -2 inside, try to simplify things around so that we get something it's very important for us. So what we will get is -2x plus 12. This is the first one. If we take -2 inside. And then plus 1 times y, this is just y, -3. And then plus we have 5 with z minus 2 equal to 0. Now we take all the numbers together. This is 10, sorry. All the numbers together and the variables together. So if we do the variables together, what we will get is -2x plus y plus 5z, and then numbers together. So what we get is 12 minus 3 minus 10, this is -1 equal to 0, and this will be the equation for the plane. So in this exercise, which is example number 3, we want to find the equation of a plane that passing through the point 4, 0, -3, and we have a normal vector I with j and k. So we have the normal vector, so all what we need to do is to write the equation of the plane, which is, it has ABC, A will be with the x minus x naught, B will be with y minus y naught, and C will be with z minus z naught equal to 0. Now, the first step we need to do is to know what is the value for A, B, C. Remember, the value for A is the number in front of I, the value of B, the number in front of J, which is 4 in this example, and the number in front of K is my C. So A will be 1, B will be 4, C will be 1. And then we have x minus x naught will be the number here, which is 4, plus y minus 0, plus z -3. Remember, we have double negative, so it will be a positive in a second. So finally, we get x minus 4 plus 4y, because 0 will just disappear, plus z plus 3 equal to 0. Now, usually we bring the variable together, so x plus 4y plus z, and then plus or minus 1 to be -1 equal to 0, and that will be the equation of we have the solution. Now let me write in the solution here, we want to find the equation of the plane passing through this point and perpendicular to this line. So the idea is the normal vector of the plane is the vector that is parallel to the line. How do I know that? Because the line itself is perpendicular to the plane. So my vector n will be the same as the vector of the line. So my ABC will be the same ABC for the line. Now what's ABC? Remember, it's the number in front of the parameter, which is the number in front of t. So for the x will be 3 because it's 3 in front of t. For the y, it's -1. And for the z is just 4. Now, again, we can write the equation of the plane. So the equation of the plane, an equation of the plane. How can we get this? An equation of the plane is through the equation a, b, c. And then here we have x minus x naught, y minus y naught, and finally z minus z naught equal to 0. Now what is ABC? It will be just 3, -1, and 4. And those are x negative, what is the point? Is 2, 0, and 1 equal to 0. If we simplify this one, this will be 3x -6. This will be just -y, and this will be 4z -4 equal to 0. If we bring all the variables together, this is 3x -y, and sorry, this is z, plus 4z and minus 10 equal to 0. And this is an equation of the plane. Now, sometimes it is good practice to check if your answer is correct. How we can check if my answer is almost correct? Look at this point and substitute it here. So take x equal to 2, y equal to 0, z equal to 1, and check in your calculator, do you get 0? Let's try it. If we substitute 2, this will be 6. If we substitute 0, this will be 0. And if we substitute 1, so we get 6 minus 0 plus 4 minus 10, the answer is 0. So my answer is correct. And that's how we can. So here we have the solution for this question. In this question, we have a plane. And we have 3 points on the plane. I will call them A, B, and C. Now, to find the equation of a plane, I need 2 important informations. I need a point on the plane. And in this case, I have not just 1 point, not 2 points, I have 3 points. So choose any one of them. I will choose the first one, which is this one. I will call it A. And this I will call it B. And the last one I call it C. And then what we need more is a normal vector. A normal vector means it's a vector perpendicular to the plane, vector that is orthogonal to the plane, vector that is coming outside the plane. So that's what we need, a normal vector, which is n. Now, how are we going to find the normal vector? We will use the idea, if we have 2 points, we can get one vector between them. So I will have a one vector here, I will call it AC. I will have another vector, I will call it AB. Now these 2 vectors, both of them lies on the plane because the 2 points are on the plane. If I do the cross product, I will get the third vector, which is orthogonal to both of them. Orthogonal to both of them, it means orthogonal to the plane. So the idea here is my n, my normal vector, will be, I will take AC here, and I will cross product with another vector, which is, we call it AB in yellow. It doesn't matter the direction as long as we are starting from the same point. Now, what is the vector AC? The vector AC is the one, I find it by subtracting C minus A for each component. So this will be, first of all, the vector AC. It will be -2, -2, it will be -4, and then -3, -1, it will be again -4. Finally, it will be 1, -2, it will be -1. This one, I will cross product it with the yellow one, which is B, which is the vector AB. How to find the coordinate of the vector B? It will be 1, and then it will be -9, comma, finally it will be just 4. Now this is just the usual cross product, so you will have I, J, and K. I will do this with color so we don't miss it. It will be -4, -4, -1, and this one will be 1, -9, 4. Do you remember how we do the cross product? First of all, we cancel the row of I, column of I, to find the component that will be with I. So the final answer will be something with I, negative something with J, plus something with K. Let's find the number of I. So we cancel this, and then we do the cross product. Minus 4 with minus 4, 16. Minus 9, it will be just 7I. Next one, we cancel the row of J and the column of J, and we do the cross product. So again, it will be 16 minus 1, so that's 17. And finally, I will do the K, which is cancel the row of K and column of J. This would be 36 plus 4, and that will give me just 40. So I have A, I have B, and finally I have C. Now if you have A, B, C, and you have a point, you easily can find the equation for the plane. Let's write the final answer here. So we say the equation of the plane. Write the equation of the plane, which will be A, B, C. A will be x minus x naught, plus B will be y minus y naught. Finally, C will be z minus z naught equal to 0. What is A, B, C? Those will be 7, negative 17, and 40. 7, negative 17, and 40. And finally, here we'll have x minus 2, y minus 2, and finally it will be z minus, this time will be minus 2 here, and this will be 1 here, just for the sake of completion. And finally, of course, we can just deal with this. So the final answer will be, if we just simplify it, it will be 7x, negative 14, negative 17y, plus 17. Finally, 40z minus 80 equal to 0. Now, if we bring the number together, this will be 7x, negative 17y, plus 40z. Finally, we have negative 80 plus 17, negative 14, and that will give me, all in all, the final answer here. And that is the equation for the plane.